Ever wondered how DNS and DHCP configurations work on switches? Let's dive into the world of network communication and unravel these mysteries together. First off, let's talk about DNS, also known as the domain name system. This is the phone book of the internet. When you type in a website's name, your computer uses DNS to retrieve the website's IP address. Without DNS, you would have to remember a series of numbers for every website you want to visit, which is, let's face it, not practical at all. On the other hand, we have DHCP, which stands for Dynamic Host Configuration Protocol. This is the protocol that allows network devices to automatically get an IP address. It means when you connect your device to a network, DHCP assigns it an IP address so it can communicate with other devices on the network. Now, where do switches come into play? Well, switches are key players in network communication. They connect multiple devices on a LAN or local area network and use packet switching to receive, process and forward data to the destination device. But here's the kicker. Switches can also be configured to support DNS and DHCP services. This means that a switch can help your devices find the IP address they're looking for and assign IP addresses to devices on the network. That's quite a lot of responsibility for a single piece of hardware, isn't it? So, how do we configure DNS and DHCP on switches? That's exactly what we're going to explore in this video. We'll walk you through the process step by step. And by the end, you'll be able to configure and verify DNS and DHCP on switches like a pro. By the end of this video, you will have a clear understanding of how to configure and verify DNS and DHCP on switches. So let's get started, shall we?
Let's dive right into configuring DNS on switches. As we know, the domain name system, or DNS, is a crucial part of network infrastructure. It translates human-friendly domain names into IP addresses that computers can understand. But how do we set this up on our switches? First, we start by entering the global configuration mode. We do this by typing in the command configure terminal into the switch's command line interface. This command allows us to make changes that will affect the whole device. Next, we need to specify the DNS server that our switch will use to resolve domain names. We can set this up by using the IP name server command, followed by the IP address of our DNS server. For instance, if our DNS server's IP address is 10.0.0.1, we would type IP name server 10.0.0.1. This command tells the switch where to send its DNS queries. After setting up our DNS server, we need to configure the domain lookup feature. This feature allows our switch to perform DNS lookups. By default, this feature is enabled. However, if it has been disabled, we can turn it back on by typing IP domain lookup. Finally, we can set the default domain that our switch will use for its DNS queries. We do this by using the IP domain name command, followed by the name of our domain. For example, if our domain is TechSpectrumPro.com, we would type IP domain name TechSpectrumPro.com. Once we've made these configurations, we need to verify them. We can do this by using the show running config command. This will display the current configuration of our switch, allowing us to check if our DNS settings are correct. And voila! You've just configured DNS on a switch. Remember, these steps are not just a one-time setup. As your network evolves, you may need to update these settings to align with changes in your network architecture. That's how you configure DNS on a switch. Now let's move on to DHCP.
Now let's get into the meat of configuring DHCP on switches. First off, we must understand that the Dynamic Host Configuration Protocol, or DHCP, plays a crucial role in network management. It automates the assignment of IP addresses, subnet masks, default gateways, and other IP parameters. So, when configuring DHCP on a switch, we're essentially enabling this automation. The first step is to enter the global configuration mode. You can do this by using the command configure terminal. This command allows us to make changes that affect the entire switch. Next, we create a DHCP pool for our network. This is done by using the IP DHCP pool command followed by the name of your pool. For instance, IP DHCP pool TechSpectrumPro. This pool will contain the IP addresses that the DHCP server can assign to hosts. After creating the pool, we need to specify the network and subnet for DHCP. We do this with the network command followed by the network ID and subnet mask. Something like network 192.0.2.0.255.255.255.0, for example. The default router command is used to specify the default gateway, followed by the IP address of the default gateway. For instance, default router 192.0.2.1. We then set the DNS server that will be used. This is done with the DN server command followed by the IP address of the DNS server. For example, DNS server 192.0.2.2. Lastly, don't forget to exit back to privileged exec mode by using the end command. To verify our configuration, we use the show running config command. This will display the current configuration of the switch, and you should see the DHCP settings we just configured. And just like that, you have configured DHCP on your switch. This process, while technical, is fundamental in ensuring efficient network management. Remember, practice makes perfect. So don't hesitate to try out these commands and configurations in a safe virtual environment before applying them to a live network. You may be wondering, what role do switches play in DNS and DHCP services? Well, switches serve as the backbone of any network, connecting multiple devices and facilitating their communication. In the context of DNS or Domain Name System and DHCP, which stands for Dynamic Host Configuration Protocol, switches play an instrumental role. Let's talk about DNS first. As you may already know, DNS is like a phone book for the internet. It translates human-friendly domain names into numerical IP addresses that computers use to communicate. Now, imagine a situation where your device wants to connect to a website. It sends a DNS query, which needs to be forwarded to a DNS server. Here's where switches come into play. They ensure that these queries reach the right server. Similarly, for DHCP, the role of the switch is equally crucial. DHCP automates the IP address configuration process for all devices in a network. When a device connects to a network, it sends a DHCP request for an IP address. The switch, acting as the intermediary, passes this request to the DHCP server and then delivers the server's response back to the device. So, essentially, switches are the network's traffic controllers for both DNS and DHCP services. They ensure smooth and efficient data traffic flow, helping to keep the network running smoothly and efficiently. By directing DNS queries and DHCP requests to their respective servers, switches facilitate seamless communication between devices and the internet. In addition, switches also provide security within the DNS and DHCP processes. They can be configured to restrict access, allowing only authorized devices to send or receive DNS and DHCP traffic. This adds an extra layer of protection against potential threats and is a key aspect of network security. So to sum up, switches play a pivotal role in the operation of DNS and DHCP services. They not only ensure that DNS queries and DHCP requests reach their respective servers, but also provide a layer of security by restricting access to authorized devices. So switches play a crucial role in facilitating DNS and DHCP services. Alright, let's do a quick recap of what we've covered. We've taken a comprehensive look at the configuration of both DNS and DHCP services on switches, two critical components for the efficient operation of any network. We began our journey by understanding what DNS and DHCP are and how they function on switches. DNS, or Domain Name System, is the phone book of the internet, converting human-friendly domain names into IP addresses that computers can understand. DHCP, or Dynamic Host Configuration Protocol, on the other hand, dynamically assigns IP addresses to devices on the network, ensuring no two devices have the same IP address. We then moved on to the practical aspect, the configuration of these services on switches. We walked through the process of configuring DNS on switches, starting by entering the global configuration mode, setting the IP domain lookup, and then the IP name server followed by the IP address of the DNS server. Following the DNS configuration, we explored the steps to set up DHCP on switches. This involved creating a DHCP pool, defining the network and default gateway, and finally, setting the DNS server. We also covered how to verify these configurations using the show commands. Next, we delved into the crucial role switches play in these services. We discussed how switches, being an integral part of the network infrastructure, facilitate the smooth operation of DNS and DHCP services. They route DNS queries to the correct destination and distribute IP addresses assigned by the DHCP server to devices on the network. And there you have it, a step-by-step guide on how to configure and verify DNS and DHCP on switches. This knowledge will equip you to manage and troubleshoot networks more effectively, bolstering your skills as a network engineer. But remember, this is just the tip of the iceberg. There's a whole world of networking concepts and technologies waiting to be discovered. So stay curious, stay dedicated. Thanks for tuning in, and remember to keep exploring, keep learning.